algorithm, which is naive Bayes. What does it do is it's more for classification and uses Bayes' theorem of probability to, with an unknown data set, put into the class. There's a very heavy assumptions in this model where predictors of a class such as the features are to be independent from one another for probability's sake. How do you build this simple naive Bayes algorithm is that, let's say you have a data set, you convert it to a frequency table, and then you calculate all the probabilities of every item, and then there's a posterior probability with the highest that will predict what the data set will belong to which class. And there are basically three models. Gaussian, which is the most left, it assumes a normal distribution in the data set, whereas multinomial, which for discrete such as binomial and Poisson. And lastly, which is a binary data, which uses the third models of the algorithm. And this is just a code where you use Gaussian and there's two arrays and they predict the class. So another thing that you can try is with regex. How do you say? So this is on Jupyter. So basically, I already ran the code. So basically, it's using regex for a data set with text, basically email, classified as spam or the relevant emails. And meaning then you use this is a multinomial because it's more of a binomial distribution, and you classify and predict for you what's the probability of you for belonging to the class. So that's how you can use even for text data sets. So in short, the strength So in short, the strength, I'll just summarize quickly, is a low complexity because it's very simple and can be faster than any of the more complex algorithm. There's some limitations definitely. For example, if there's a zero probability case and the independent assumption is actually very strong in reality. Now for independent assumption, actually that's rather hard to mitigate. What you can mitigate was more of the zero frequency things and also reduce some correlated features so that you increase the independence of your data set. So that will be the algorithm itself.
Yep, thanks, Solomon. So, as Solomon mentioned just now, his code was used to run an example on identifying spam emails. So, other applications for this naive-based algorithm in real life, there are many, such as news categorization, face recognition, sentiment analysis for social analytics, medical diagnosis, and if you don't understand just now the codes very well, like me, what I'll be doing now is to go through a very simple example of weather prediction without using much codes. Yep. So for example, if we look at if someone who wants to decide whether to go for outdoor sports and he doesn't know whether it will be a good time to go because of the various weather combinations. So over here we have 3 different seasons and whether there's sun and whether there's wind. So what the person can do is to note down all the different days and combinations and the different results in the past, and then use the naive-based probability to come to a conclusion. So for example, if we look over here, we can see he plot out a graph on the y-axis whether it's sunny or not, and for the different climates, and the big circle means that the probability is more than 0.5 and the small circle is less than 0.5. So if you go in deeper further into the right chart, assuming that it is not sunny, there is still another factor where we consider the wind. So again, you also plot the different probabilities. So for example, there's one grid here that you don't really know what is the probability. So this is where the naive-based algorithm comes in. So using the same formula as Solomon mentioned just now, what here we want to find out whether it is good to play football on a winter season when there is no sun and where there is wind. Okay, so first what we do is to calculate the frequency table in the past. So for example, how many days, how many times it was good to play on summer, monsoon, winter, and then you calculate the likelihood, which is basically calculating the probability. So after you find all the different information to fit into this formula, you will finally arrive at a probability of, using this simple example, you arrive at a probability of 0.6, so which is more than 0.5, and which means that it's actually good to go and play. So that is a very simple case of non-coding simple case of naive Bayes algorithm. And with that, come to end our presentation. Thank you.